all the stuff we've built, hear about it. And today I'm going to be talking about the stuff we're planning on building going forward. So I'm mostly going to be talking about Biolearn and the challenge and one other tool that doesn't quite fall in that category. So as far as the challenge is concerned, we have phase 3 coming up, which I think most people would consider the most exciting. But before we talk about phase 3, I'd like to talk a little bit about what we learned in phase 1 and 2. So I think one thing we learned, as Albert talked about, is that these kinds of competitions can produce some impressive results. So we had, many models that had sub 3-year average air, which is better than any of the published models that we used. But as we moved into phase 2, we ran into some issues. So we realized that data access was a big problem for a lot of the teams. So there's a lot of data available with omics data and age, but there's not a lot of publicly available data that could be used for training that has methylation data and mortality outcomes for people. We had a number of our teams talk to us about this, and we also had less teams able to participate in our challenge because of that. Another thing that we realized is that picking the right metrics for a competition is hard. When you have a competition, people are trying hard to game the metrics. And here we have two of our participants, two of our winners in the first phase, who were having a little mini challenge where they tried to see how badly they could break our metrics. So we had to pick a new one. So with those in mind, let's talk a little bit about phase 3. Phase 3 is going to be the big challenge. It's going to be 100K total prizes. And we're actually not going to be launching until July 1st. And that's going to allow us time to see what we can do to help with the data situation, as well as we want to put out the challenge judging criteria early and allow time for community feedback. So we're really excited to get started on that. We're also going to be working on Biolearn in 2025, and this is not comprehensive of the things we're going to be working on, but we will be definitely having a big focus on proteomics and metabolomics. We've got a collaboration with a group of Harvard students called the Aging Initiative to build better data visualization and analysis tools. And we're also going to be including some more complex models that are nonlinear. So I have 4 other projects I want to talk about here, which I'm calling community projects because we need help from the community to make them a success. So the first one is pretty simple. We're actually building out some documentation for what the IP situation is for each of these clocks. So these are all free, they're open source, but we've had people ask, can I use this commercially? And we didn't know the answer to that. So we have some of the answers, and you can go and look at this right now on Biolearn. If you go to the models page, you can click through to this page. And if you know the IP, you own this model or something, and we don't have it correct, then please let us know, and we'll add it to the list so that everyone can know. So we also have released a methylation data standard. So this is part of the reason we did this is that if you've been on Geo recently and seen something like this, this is the methylation matrix, and that used to be in the series matrix file, which is this one right here. And when it was in the series matrix file, it was all formatted the same way. And now when it's in this file, it's not all formatted the same way. There's not really any standard for that. And so it makes it really hard for people to reuse this data to make it machine readable. So people spend a lot of man hours to try to fix that. So, and we'd also like to make metadata more consistent. So there's a lot of useful metadata in Geo, but it's not necessarily formatted in a consistent way. So we have this methylation data standard that we put together. And it's really simple. It's a way of describing how to format your files so that they can be machine readable and transferred from place to place. And if you're writing a library, please use this. And if you don't like it for some reason, don't want to use this, let us know why, and maybe we can fix it. And it's also helpful for biobank data sets that have very large numbers of samples. You can also check this out on our documentation there in the QR code. So this project is one that I'm very excited about. We're calling it federated benchmarking. If you go to this QR code, we actually have a website that you can see, and you can actually submit a clock, a methylation model, and it'll show you how well it performs. So first of all, we're going to provide an interactive view of the performance of these different models on on different data sets. But you can also submit a model to this, and we will evaluate it against data sets that you may not have access to. So the idea here is that we're going to provide a benchmarking tool that will allow objective evaluation of the performance of different models on the same data sets. And I forgot, I want to do a shout out to AI for Life that helped us put together that demo. I was supposed to do that, but I forgot. So the long-term vision of this is that you would be able to run any type of model. So we'll use containerization. You can run linear models. You can run deep learning models. And then we're going to have many different data sets with many different omics types and many different outcomes associated with them, so that different types of models with different types of predictions can be tested. And we think this could be the best objective standard for comparing different biomarker models that may be produced. A lot of times researchers are using just the data they have access to, and that is not going to be the same between different papers that are published often. So if you have access to a data set, a private data set that you think could be made available in this way, please get in touch with us. We'd love to incorporate as much data as we can on this platform. So the last project I'd like to talk about is this idea of proprietary model support. So in Biolearn, we have many open source models. We would also like to support models that are not open source. They're closed source. And we think this could be very useful because industry has spent a lot of effort developing their own biomarkers, and they need validation. So if we give access to academic research, they can test these models, see how they perform, see if they can validate them. And then if they're validated, then they can use these models in research for aging and health. So we found some people that agree with us that this is a good idea. So we're going to be working with a company called Hurdle that developed a clock in collaboration with Bayer. It's an inflammation aging clock called InflamAge. And we're going to be able to use it just like you would any other model. So if you've used Biolearn, this will look pretty familiar. This QR code will give you a little more information about the model, but the idea here is that Hurdle will be allowing academics to run this model for free. So once you get API access, you can then use this model in Biolearn, and their IP will remain protected. So they're not open sourcing their model, they're not sharing their weights or anything like that, but they are allowing usage of the model. And we think that this could be a really great exemplar for future integrations. And I'm going to pass on to Dane, who's going to bring up some people who worked on the model.
Thank you, Seth. And as you said,